we want to consider what happens when we start multiplying algebraic expressions. So let's start with something simple like 2x cubed times 3x squared. Since we're taking a product, we can use the commutative property of multiplication, and we could rewrite this as 2 times 3 times x cubed times x squared. Then we could use the associative property of multiplication and group things like so. And we could say 2 times 3 is 6. And then if we have 3 factors of x times 2 factors of x, that gives us a total of 5 factors of x. So we get 6x to the 5th. As you move along in algebra, you usually don't write the intermediate step. You simply write, you would see this and you would multiply the constant terms and, the constant factors, and then you would multiply the factors of x together and know right away that it's 6x to the 5th. But the reason why is because of the commutative property of multiplication and the associative property of multiplication. So those are our justifications. Now, what happens when things get slightly more complex? Let's take a very simple monomial like 2x, and instead of multiplying it by another monomial, let's multiply it by a binomial like x plus 3. We know from what we talked about earlier with the distributive property that what we need to do is we need to multiply the one term that we have for the first factor times both terms of the second factor. So if we do that procedure, we know that 2x times x would be 2 times x, or 2x squared. And we know that 2x times 3 would be the same as 2 times 3x. 2 times 3 times x, which would be 6x. If we want to be able to visualize this, we could think of a box. And let's just pretend we don't know what x is, but let's just pretend that length happens to be x. And so what would the first term be? It would be x plus x, or 2x's. So if we put x plus x, we have a length of 2x on this side. How long is the other side? Well, the other side is x long. And then let's change colors here. And then 3 more units. Now, we don't know if 3 is bigger or smaller than x. So let's, in this case, just say that 3 is a little bit bigger than x. And now we need to figure out, multiplication is like figuring out the area of this box. And so this part of the box would be our first term. When we multiply a base of x times the height of 2x, we get an area of 2x squared. And the second part of the box would have a base of 3 and a height of 2x. And so we would get an area of 6x. And since 2x squared and 6x are not like each other, we end up having to leave them as separate terms in the result. So we can distribute 2x times x plus the quantity x plus 3 and get 2x squared plus 6x. Let's consider another example. Let us consider 2x times x minus 3 instead. If we follow our procedure of taking 2x times both factors in the, both terms in the second factor, we would get 2x squared when we multiply 2x times x, and we would have minus 6x when we multiply 2x times the negative of 3. What would this look like visually? Let's consider that. It would be, once again, like having a box that is 2x's tall, and then on the other side it would be x long, and we could multiply all of that together and get our 2x squared that we had before. But now here's the tricky part. Instead of adding on 3 like we did last time, we have to take 3 away, and this gets very hard to visualize if x happens to be less than 3. If it's more than 3, we could think of, if x is more than 3, we can think of cutting off a section of the area that we've already created that is 3 units wide and 2x tall. So we would take 6x away from the original 2x squared that we had laid out from the first part of the product. So the result would be 2x squared minus 6x. So we can think of subtracting areas out for negative terms. Let's continue on and have one final example. Let's consider what would happen if we had a more complicated monomial like 2x cubed and multiplied that by a binomial like 3x squared plus 4. Procedurally, we take the only term in the first factor and multiply by both terms in the second factor. You don't need to draw the arrows in, but you should be thinking about them. And so, like our first example, we know that 2x cubed times 3x squared will give me 6x to the 5th as a product, and the product of 2x cubed and 4 would simply be 8 times x cubed. So the result of that would be 6x to the 5th plus 8x cubed. Now just one final note. Notice that when we do this multiplication, we have one term times two terms, and we were thinking about this as multiplying lengths along sides of boxes. So if we have one length on one side and two on the other, we'll get a total of two different terms. So one term times two terms will always result in having two terms.